Good evening to one and all. So, this is Dr. Akatik, and in our lecture series for control system, today's topic is going to be the analogous system. So, what is this analogous system? Now, two systems are said to be analogous to each other if the following two conditions are satisfied. That is, the two systems, they are physically different, but the differential equation modeling of these two systems are the same. Now, when these two conditions are satisfied, now we can say the two systems are analogous to each other. Now, in our previous lecture series, we have seen the modeling of two basic systems, that is the mechanical system and the electrical system. So, mechanical system, we have three basic components, that is the mass, spring and dashpot. Now, whereas in electrical system, now we had the resistor, inductor and the capacitor. Now, here in today's lecture series, now we are going to see what are the analogous or relation between these two systems. So now the electrical system and the mechanical systems, they are two physically different systems, but their differential equations, they are going to be the same. So there are two types of electrical analogies of the translational mechanical system. Two analogies. One is the force voltage analogous system, the other one is the force current analogous system. So these are the two analogous system for that is electrical analogy for the translational mechanical system. Now we are just in our today's lecture, now we are going to see what is this force voltage analogous system and what is this force current analogous system. Now you can see for a translational mechanical system, the input is nothing but the force what we are going to give. The input is the force. Whereas the same thing in electrical system, the input in this case is nothing but the voltage. So therefore, the system is called as the force voltage analogous system. It is based on the input. Force is the input in a mechanical system, which is analogous to the voltage for any electrical system. The next one is the mass M of a mechanical system, which is analogous to the inductance L of an electrical system. So mass M is analogous to electrical inductance of a system. And then we have the frictional coefficient. Now this is mass M, which is just represented by the mass M. It is the mass of the body. Fine. So now it is represented by the inductor of the system. So your mass M, this is the inductance L of the system. The next is the frictional coefficient. This is nothing but the dashpot. It is the dashpot, which is a piston moving inside a cylinder. So now here the frictional coefficient is represented as B, now which is analogous to the resistance inside or in an electrical system having a resistor. That is resistor having a resistance R. And then we have the spring constant, that is nothing but the third element, which is nothing but the spring, where the spring constant, that is the stiffness of the spring, it is given by K. Whereas this, it is equivalent to or analogous to the reciprocal of the capacitance in an electrical system. Reciprocal of the capacitance of an electrical system. So the three elements in the mechanical system and its analogous three elements in the electrical system we have discussed. Then displacement, this is nothing but the output. Input is force, output is displacement, and here this also you can give it as the output. Now here it can be in terms of charge Q or it can be in terms of the current I. So this you call it as the force voltage analogous system, now where the input is force in a mechanical system and it is a voltage source in an electrical system. The next analogous system is called as the force current analogous system. Now again here you can see the input in a mechanical system is force, whereas here the input is a current source. In an electrical system, the input is a current source. Similarly, the mass M in your mechanical system, now here it represented by the analogous capacitance C. Now this is the difference between the force voltage analogous system and the force current. Now here the capacitance in the previous case, it was for the spring constant K, that is the reciprocal of the capacitance. But in force current analogous system, the mass M is analogous to a capacitance C. Similarly, the frictional coefficient, again it is nothing but the dashpot. Now the frictional coefficient B, here it is represented by the reciprocal of the resistance. Okay, it is 1 by R. 1 by R. Similarly, the spring constant, now this it is represented by the spring K, which is represented by the inductance, that is inverse of the inductance in your electrical system. So the mass and the spring, now it varies between the force current and the force voltage analogous system. Now in this case the output is nothing but again the velocity and the displacement. Here it is in terms of your voltage V. So now these are the force current and the force voltage analogous system. Now how to solve problem in this, we'll just discuss in the upcoming lecture series. So thank you very much.